Yeah, so my name is Souvik Haldar, and I'm currently working as a backend developer in Card Bytes here at Kolkata. So this time I was having the task of implementing. So I'll be basically sharing what I learned. I don't have much experience though, but in the meanwhile, what I've learned, I'll be sharing with you guys. So I was having this task of implementing uh, OTP verification, mobile number verification. So a user can sign up using mobile number, and I need to check that this is possible, like signing up with phone number. So previously I implemented email registration, and then I implemented social registration using OAuth 2, and afterwards I was having this task of registering using phone number. So while going through that, implementing that, I was having one option of Twilio. Twilio had this ready-made option of sending SMS and verifying it as well. But somehow its pricing was not much friendly, so we thought of switching to something called budget SMS. So the thing was that it was very cheap. So and also the for implementing the verification, it was kind of easy. So you don't need to particularly use the one from Twilio. So I thought that maybe I can implement it myself, and the only service I need is sending the SMS. So for that we chose the one which was kind of cheap, and budget SMS was one. But while working with it, and also while working with Twilio, one thing I encountered was that there was no native support for Go. Even for Twilio, there was no support for Go, but there was for PHP, Python, and all. But while we switched to, but there was third-party libraries available for working with that. But when we switched to budget SMS, there was no support for any language. Basically, they wanted us to use their APIs. Their API is also quite easy. You can use that. So I thought that why not write a simple library which will wrap this request, and I can easily use it in my code. So for that, basically, I started working on this project called that Go Budget SMS, which is implementing the Budget SMS's API in Go. So the very simple thing it does is that it takes all the parameters. Let me show you how I implemented it. So how I implemented is that first there is an endpoint which would be, this is the endpoint handle phone number. This endpoint would be executed when you call, when you send the phone number. Suppose there is a screen on the app which says enter your phone number. You enter your phone number and there's a button in its below which says that submit. When you hit the submit, this function is invoked. What this function does is that it queries the phone number that you send as a query parameter in this case. When you get the phone number, what the first thing that you do is you generate an OTP corresponding to that. What I mean by that is that I basically used this rand function of Go to create a four digit random OTP. For that, what I was basically doing is that I was trying to get random number till 8999, and I was just adding 1,000 to it. So even if it's one, it will be four digit, and even it is 899, it will still be four digits. So in that way, although it is not much secure, but this way I was creating a random number, four digit. Then I was I was putting this number, I was putting this OTP corresponding to the phone number with the expiry time of 5 minutes. So what set value function does is that it stores the key value, I mean the phone number and the OTP, in the Redis database with expiry time of 5 minutes. I have chosen 5 minutes, that can be variable. So after that is done, I send this particular generated OTP to the phone number that I've got. So what the user gets on his phone is the OTP. Is there any question? Hello.
I think you can go ahead.
Okay.
Might be.
Okay. So yeah. So I was at this point that I was sending this OTP to the particular user. So the user at this point gets the OTP in his registered phone number, which is the number the sent, and the app gets a random string, another random string called SMS nonce. This is nothing but another random string which is sent to identify particular this particular transaction. So I am just sending this SMS nonce when the request is successful. So the app gets this SMS nonce and the user gets the OTP in the phone number. Now the second screen on the
Sorry to interrupt, Souvik. Srinatha,
okay.
can you please unmute your, can you please mute your phone?
I've done it.
I'm moving forward.
Sorry,
Okay,
I've done
thank
it.
you. Okay, go ahead.
Yeah. So at this point, the first transaction is over. That the user has the phone number, send this phone number to the server, and has opened on the app side. Window asks. Now the user enters OTP from the SMS. Now the user sends two things. One is the OTP that he has got, and the app automatically adds the nonce with it when making the second request. So when making the second request, this function is invoked with two arguments. One is the OTP, another is the nonce. Now what happens is that using the nonce, I'm getting the number from the Redis store, because I told you earlier that at the last moment what I was doing in the previous transaction is that I was storing this nonce corresponding to the phone number. Key is the nonce, phone number is the value. Now I have got back the nonce and I'm using the nonce to get back the phone number from the database. Now when I've got back the phone number, I'm using the phone number to get the original OTP, which I stored in the first place. Okay, so in the first transaction, two things were getting saved as key value pair. One was the phone number corresponding to the OTP, then the number corresponding to the nonce. So using the nonce, I'm getting back the number. Using the number, I'm getting back the OTP. So this is the original OTP, and this is the OTP. This one. And this is the OTP that the user has sent as the request in the second transaction. So finally, I'm just checking that this OTP matches it or not. If it is matching, then it is authenticated, or else not. So in this process, the only place where Go Budget SMS library was used is for sending the message here. So this is the functionality that Budget SMS offers. But for using this send SMS, you can send any message here, the number to which you want to send, and OTP is the message that you want to send. Yeah. So, and this function, how am I using it is that, see, this is the message. This is the function that I'm using. Here, I am using this send SMS option, the method of this library called Go Budget SMS. This asks for these parameters. First is the configuration, second is the message, then the to number, and whatever organization you are associated to, you just add it there. Now, how do you set this configuration? This configuration is set here. I have set it up in the init function in my personal package, where I'm using Go Budget SMS's set config method to set. First parameter is the username, second is the user ID, and third is the handle. all these parameters you will be getting when you register at budgetSMS. And these parameters, you can see later on the documentation, these are just for saying that whether you want to know the pricing details or not, or whether what is the response or not. So these are just Boolean values that you set if you want to know particular values. So this is basically the library that I've written. It is just a wrapper for the request that you make to the original Go Budget SMS's API so that you can send the message. So this is how I implemented the OTP verification process.
Okay.
Now, any questions?
Souvik, can you go to your random number generation functions again? So,
Okay. Yeah, here. This one.
yeah. Do you think it's concurrently safe to generate random number with like this?
While using concurrently, I'm not sure, but I guess this should be fine because every time it is creating a random number, and I'm just adding 1,000 to it. Although, matlab, other functions can also do the same, but but this is a very valid point and question that this can be made a bit better. But I actually chose it this way. This surely can be better.
No, so as far as I see, I haven't generated random number in Go, but I know that random numbers are all generated against a seed value.
Yes.
So
Yes.
if you take two Go routine exit, so suppose if you have a 4 CPU on your machine.
Okay.
So if you have a 4 CPU, that means 4 Go routine can execute concurrently. And if you try to test it, there is high probability chance that the two seed value can, collide, and you will get the same OTP.
Yeah. So for that, I was actually thinking to put the current time as the seed value. So do you think that?
But again, the same thing happens, right? With the current time also, it might your 4 CPU can get the same time.
Right.
So I don't think means this might cause a issue in high concurrent volume application, but right now if not that the issue, then you're fine. That's just my opinion for this.
Yeah.
Actually, sorry. Yeah, actually, I have some thoughts on this. Actually, I also work as a backend developer. Yeah, this kind of system is a little dangerous, and I'm not against it because there's another system called open. There's a system for actually developed for one-time passwords, and there are like many implementation of. One famous one was PyOTP. So I'm actually work on Python, so it's an implementation of open. I have to Google it, but yeah. So this is not advised actually, if you're going to work on scale.
Even I was thinking that this can be improved. Actually, I was just trying to test it out that if whether I can do it. So
This will
yeah,
generate.
this definitely needs improvement.
Some, yeah, and also storing in Redis also. There are edge cases it will backfire. Actually.
So
So how
any
do you
issues
go?
with storing video?
Sorry?
MFRW, how do you go about generating the random numbers in your opinion?
So actually, it's more like you can use a hashing. You can hash it with some unique key with your user, whatever you have, or a phone number. And I'm not even Gaurav, I'm also not sure about this, but
Okay.
yeah, this is what I got from my. Like, don't use this.
No, so the thing is, Gaurav, so the thing is for Go routine communication, that's where Go says, right, use channel. So instead of sending generating number like this, use communication primitive like channel. You can, so this is basically one of the fundamental principle of concurrency in Go. So instead of doing this in your own function, and so you pass it to some other function that communicates by channel. Since channel provides blocking, it just takes one primitive communication, right? So not much of a overhead, and you get a concurrent safe thing. That is one of the case you can handle this.
Implementation. Okay, right.
I also agree to the fact of sending random numbers on channels. In that way, it's less likely that you're going to collide, because eventually a random number generator is just a state function. What you do is
Yeah.
typically a LFSR or somebody, you just seed it with something and then it just gives you pseudo random numbers. It was happening, it seemed like it could really, collide.
Yeah. So how about using crypto package with it? Crypto package with some. I actually sent one link.
Yeah, sure.
You
I
are
had a
going overboard with that.
I had a question. I just now I'll quickly search it. CHEN.
So crypto package basically works with the prime number generation, and prime number generation is not CPU means friendly.
Yeah.
Yeah, right.
So I was looking at this functional options pattern where you configure, for example, when you showed us the configuration for that whatever that SMS gateway function. So you actually gave configuration params like a struct and different values of the struct. But I today itself was reading about this. I'm going to send that in the chat. So these are functional patterns, highly, kind of evangelized by Rob Pike, Dave Cheney. So any of you, could you please share some thoughts on this? How about we should configure, for example, a function that takes in a bunch of configuration parameters? How should we configure it? Should we give it a struct? Should we give it functional options? I mean, just a random, a drift question.
I was wondering that I should use this one. Actually, the motive behind it was that the structures, I will make it of small letters. I will make it private. But I will just export one function in which I will set the value so that it can never be zero. So the function could be like a constructor kind of, a function like new. In new, I will provide the parameters. I will provide the parameters, and what new will return is the structure. Fill it with the values and then return the structure.
Perfect.
But the fields and the structure would be private. That was my thought, but I didn't do it.
Yeah. You could also take a look at the link that I just sent. It's actually, I just looked it up today. It's an excellent way of initializing things. So I just wanted to know if any of you know about this and would want to share a little idea about that.
Sure, that makes sense. Um, in the interest of time, can we have this discussion like at the end of the
Yeah, exactly. Sure. I mean,
like
I
I
just
have
wanted to put it.
yeah, I get that. I mean, this is like ideal. Just we jam packed today. We are jam packed for today's
Sure.
remote meetup.
Sure.
All right. So without further ado, so I'll give you an investigative walkthrough of ghost channels. The alternate title for this talk is Learning About Ghost Channels. My name is Gaurav Agarwal. So agenda is basically starting with the audience poll, program walkthrough, deep dive into channels internals, a short demo, demo God's permit, of course. So I mean, I'd prepared this for GDP. So how many of you are familiar or have worked with ghost concurrency? I mean, this is probably the only relevant question to this audience. Okay, no response.
I have done a little bit of concurrency.
Yeah, a little bit.
Awesome. So I mean, I know Ankur is familiar with it. He has like most of. So I've taken a few of the slides from Ankur's content. So I'll go on. So the program which I wanted to talk about initially is the simple scraper. So what I have is a scraper which scrapes for a particular type of products from Amazon site. So you have TV listing page. So I'll walk you through the pseudocode of the program. I won't show you the program right away. This is the TV listing page on Amazon.in. And from there, for each product, I get its name, image, price, and link. Once I've got those products, got the product page link, I visit the products page. For example, here I'm visiting, I'm visiting MI LED TV's link page and getting its reviews. For each review, I get its name, rating, and content. Tying it all together, so in my main page, I loop through the results from the product listing page, and then I parse the result to get my product. In the past product, I go to the product page and get its review, and I just output the JSON. This is the kind of output which I'll be expecting from Amazon's page. Name, link, this is for one particular product. Name, link, image, price, and all its reviews is what I would be expecting as the output. Fair enough. To make this program, existing program in concurrent, all I have to do is add the keyword go to make the pass product act as a go routine, which runs independently of the main function, and pass a channel into it for communication. You need to communicate back to the main function. Fair enough. So for each of the results, for each of the product in the product listing page, I would be visiting the product page and then getting its reviews concurrently. So the main source, so everything looks simple in this code, especially because I'm using the power of channels. So diving deep into Go's channels, so Go has two kinds of channels. One is the buffered channel. The other is the unbuffered channel. A buffered channel has a length of n, and unbuffered channel has a length of 1. So when you're making a channel,
may I interrupt for a moment? Yeah, so when you said unbuffered channel has a length of 1.
Yes.
So
unbuffered.
Sure about that?
I'm sorry, who is this?
Money.
Oh yeah. So unbuffered channel has a length of 1. In the sense, it can only communicate with. So the buffer size itself is 1. Okay. Shall I take the questions at the end of the talk, Money, if you don't mind?
Yeah, sure. Yeah.
Yeah, because I'll make this clear. I'll make it super clear. So one day I was just curious as to how channels really work. I just wanted to go look at channels. I added a breakpoint on the writing to a channel code and also reading from a channel code in my project. So it seems like we have 10 more minutes in this meeting. We'll have to reconnect back. Sorry guys about this interruption. Anyways, I'll move on. So the channel. So looking at the channel structure, so I've added a watch. I'd added a watcher on this. The channel structure has interesting properties. So PCH has a queue count, a data queue size, a buffer, element size, close, element type, send X, receive X, receive Q, send Q, lock. A whole lot of internal structures. So where do these come from? All of the properties of a channel come from a structure called the head channel. The headchan is is a is a normal Go structure, which has fields of type information, buffers and queues, counters, locks and flags. So we'll go into each of the types. So the type information is contained within element size and element type. The element size represents the size of a single element in memory in bytes. Size of a single element to be stored or passed around in the channel in memory. So my channel holds product. The product structure is of type has name, link, image, and price, which are strings, and reviews, which is a array of review. So it takes about 88 bytes. So this structure, by default, a null product would take 88 bytes in the in memory.
Gaurav, just a second. I would also like to know if you restructure your struct, because I might forget. Just go back to previous slide one.
This one?
No, the product structure.
Yeah.
Yeah. So if you replace the review from bottom to top, what will be the structure size? I would really like to know about this.
We can try this out. Okay, cool. So it still is 88.
Okay, thank you. Because I was okay, it seems like we have got upgraded.
Yep.
Because I was thinking, might be memory alignment. Does memory alignment cause any issue with this size? Or
no, it doesn't actually. It's not. So it's not about contiguous memory. So string, link, so strings and arrays are not stored in the stack in the whereas
yeah, got it.
So element size looks at the memory in the stack, whereas whenever you initialize a string or a review array of review, that would get stored in the heap. So each of the individual attributes will be stored in the heap. So that's why it takes 88 bytes. So it's a standard 88 bytes. Irrespective of what the length of the string is, this structure, this product will always take only 88 bytes. So similarly, so it looks at only the size which it takes on the stack, not on the heap element size, basically. So similarly, integer would take only 8 bytes. Moving on, so you have the element type. So this is a special attribute within the headchan struct. This, apart from size, it's duplicative in a sense. It has the size information again. It has the pointer data, hash, TF flag. I'm not exactly sure what each of these attributes do, but the way it's used internally in headchan in the runtime chan.go file is that it consists of proper type information. Like whenever the messages, so Go has this paradigm. Go prefers sharing data by copying. I'm not sure if you guys have heard of, if you're familiar with that. So the idea of Go is you don't communicate by sharing memory. You communicate by copying over data. So when the Go routine actually sends, so when you send a data over a channel from Go routine A to Go routine B, the information gets copied over. Element type helps in Go runtime to determine what the type information of this element is and how it should treat it and copy it over from one Go routine to the other. Moving on, so buffers and queues. So buffer. So, okay, so this is where Mani's question comes in, right? What's the difference between buffered channel and a unbuffered channel? So a buffered channel and an unbuffered channel both have a buffer. The only difference is with a buffered channel, the buffer is of size n. So here the size of the buffer is 3, and hence you have 0, 1, 2 slots into the inside the buffer, inside the circular queue. So think of the buffer as a circular queue. In an unbuffered channel, you just have one single buffer. Actually, it doesn't really have a buffer. It doesn't really need a buffer. Like a circular buffer is not required. But it still reuses the head channel. Correct me if I'm wrong, Ankur.
No. So basically what happens in buffer channel, you get a circular buffer. With unbuffered channel, you get an array of length 0, 1.
Yeah.
Uh,
Array of length 1, but it's still a buffer. In the sense, it's still the same structure. It still maintains the same structure. It just, the semantics changes. The data queue size becomes 1. The queue count would always be 0 or 1 at max. I'll come to these two values, these two attributes, data queue size and queue count, in a later slide. Let me go on. So what are queues, right? What is this receive queue and send queue? So receive queue and send queue both are of type pseudo-G. Pseudo-G is this special type which basically holds the information of where you are writing from or reading from the channel. Like it's a pointer. It's a runtime information of which Go routine has called this channel, is trying to read or write to this particular channel. So this is what receive queue and send queue hold. This is pretty much the structure of the receive queue. If you look at it, it's a linked list. It's a doubly linked list, which has the first and the last node. The first node in turn has a previous pointer, which is null, and the next pointer, which is the next Go routine, which is going to read from this channel. I hope I'm making sense. I'm not going too fast. We have ample time, so actually I could take questions in the middle of the slides. All right. No questions. I'll assume like everything's clear. Moving on. So receive queue and send queue have unlimited size. Like you could read from as you could hold as many Go routines as possible, trying to concurrently read from a channel. And similarly for send queue, you can have as many Go routines as possible to send to a particular channel. All these so the Go routines would stay in these receive queue and send queue for as long as they are blocked. Blocking happens when so that's determined using the counters and send x and receive x. So queue count gives the size. So data queue size determines the total size of the buffer. When you create a channel, you pass it a size. You say n3, then data queue size would be 3. If you create an unbuffered channel, data queue size would always be just 1. Queue count, on the other hand, determines how many how many slots in the current buffer have been filled. So queue count, so if one element in the buffer is filled, then queue count would be 1. Once queue count reaches 3, and once the data queue size and queue count become equal, receive queue and send queue block. Send queue blocks. When queue count is 0, receive queue blocks, send queue is not. Like data can be sent to the channel.
Yeah.
Awesome. Moving on. So this is one other representation. So I've picked this from Kavya Joshi's slide. By the way, the previous the CQ this diagram I picked up from Ankur's slide, Ankur's blog post. Do read it. I've added it as a reference at the end. This one is from Kavya. So this one, here you have a buffer channel. Again, the same thing, just a different representation. So you have buffer, send X, receive X, and lock. I'll not talk about the lock right away. I'll talk about it in the later slide. So you have a buffer of size 3. Everything is empty. Send X and receive X would be 0, 0. So send X and receive X basically hold pointers in the circular queue. If you're familiar with the circular queue implementation, it needs it needs to maintain indices of where reading and writing can be done from. So that's what sendX and receiveX are. They are basically integers which hold information on where it can write. So since sendX and receiveX is 0, so receiveX is 0, when a channel tries to write into this buffer, it would fill the slot 0. And now, so sendX becomes 1, and now the next channel which tries to send, the next go routine which tries to send to this channel, it will fill the slot 1. Let's say all the slots are filled up. So now again, all the indices are reset. They're back to 0, 0. But since queue count and data queue size have become equal, no more sending can be done on this channel. Like the channel would basically block on any subsequent send. This should be clear. One DQ happens, receive X becomes 1. Send X still is 0 because the pointer still, so if a channel comes in and tries to send, it would fill the slot 0 and send X would become 1. So the next channel which reads from the channel, next go routine which reads from this channel would start reading from 1. So it maintains a order. So so channels by default are first in first out queue. They are yeah, that's one property you'd have to keep in mind, the first in first out property, and that's maintained using the buffered queue. Sorry, circular queue. Right, moving on. Right. So we have flags and locks. So we have the close flag, which is self-descriptive. It just marks the channel as closed. When you close a channel, this flag is an integer. It gets marked from 0 to 1. That's all it does. A lock. So the lock is the more interesting bit of thing in the headchan struct. So this is a mutex which controls reading, sending, and receiving to a channel. It ensures that all the go routines which are running concurrently, they do not end up sending or receiving concurrently at the same time. Like they do not update the buffer state as well as the send X, receive X, as well as the receive queue and send queue queues. So channels are blocking. Channels have are thread safe due to locks. Seeing debugging in action. So this is pretty much the demo which I have planned. I actually rushed through the slides much faster than I could, than I should have. Anyways, I get more time to debug this program. So this is the same program which I was talking about in the beginning. So I'm getting the So I have added a breakpoint on the receiving as well as the sending of product. So I hope the screen is visible. I could increase the font size. Yes. I have. Is it much better? You could speak up. Okay. I'll increase the font size further. Yeah. I actually won't have space for anything to show anything if I increase it further. So the gist of the code is that I'm creating a buffer channel which is of size 3. I'll go back to a unbuffer channel and show its behavior. But with the buffer channel, now if I like I'm just continuing the code, I'm continuing to run the code. So now it's writing into the channel. So the receive queue and send queue had been updated. Now you have one write to it. See, immediately the send happened. I'll go on running it. Yeah, just keep the watcher. The more have to yeah. So this is more of a hit or miss demo. I'm actually yeah, okay, awesome. So this this happens when two successful sends happen. So now the buffer is filled with one, and the send did and the receive did not immediately happen. Like this code did not run like simultaneously. Like two sends already happened in this 27 line 27, and after which one read only have been executed. So now you could see that the queue count has increased. Now my buffer would have one product, and so yeah, it doesn't actually show me the product. Maybe I could do something like this: ch dot path of one. If I do that, probably I will get it. Yep. Whereas if I do one, I shouldn't get anything. So only the so only one of the buffer is filled in this case. One item in the buffer is filled in this case. So going on, should be empty. So once it's empty, yeah, queue size has become 1. SendX and ReceiveX are on 2 and 1. That means my data is actually not in buffer 0, but it's in the location 1. In 2, it would be empty. In 0, it would be empty.
No. Gaurav.
Yeah.
Actually, that does not mean data is empty. That means from next position, because since it's a circular queue, that actually signifies from which position it has to, from where to read and where to write.
Right.
That it's
right. But if you look at the queue count in the previous example, the queue count was 1. So based on that, you can determine if the buffer has only one slot filled or it has multiple slots filled. So right now I know queue count is 2 and receive X is 1. That means the 0
read
and
from,
the second.
Read from position 1. Yeah.
So first one and the second slot would be filled in this case. Because the send X is 0, that means the next write is going to happen on the first slot of the buffer. This is, I know it's confusing. You'd have to I should probably prepare a GIF for this. I could go back on to that slide. So yeah, pretty much what you're seeing is the circular buffer in action for the output. This is where I should be getting the output. And I'll stop the execution of this program. I'll go on to the execution of the program with the unbuffered channel. Sorry. So pretty much everything is the same. Data queue size is 0. Queue size is 0, and buffer is basically an array. It's still an array which has just one item. Let me execute this. I'm just waiting for it to execute. So it has received. So receive is blocking. Send queue is still empty. Now it has received. It has passed out data. Oh yeah. One property of a receive queue and send queue is that the way the scheduler works is that when it sees that there is a receive by sending, if it sees that there's already something in the receive queue, it would, instead of copying things into the buffer, it would directly send it to the receive queue's element and into the receive queue's position, memory location, and not even touch the buffer or even update any of the counters. So yeah, that's taken care of by the Ghost scheduler. The same thing happens even with the unbuffered queue. Oh, sorry, buffered channel.
Yeah, so I also wanted to ask a question. I mean, okay, so what did you exactly mean by, see, because I can see that the data queue size is currently 0 in case of unbuffered, right?
Sorry.
The data queue size in case of unbuffered channel
is 0.
Yeah, so so is the queue maintained or not in case of unbuffered?
It is, in the sense, it still has a buffer where the element is stored, like the element product.
Yeah, obviously, obviously.
Yeah, it's still stored inside this buffer. It's just that I haven't gotten lucky enough where 2 writes have happened and only 1 read has happened. Let me just go on executing it a bit for a while. So it seems like, yeah, now I have like some send, blocking send. So that means I have something in the queue. Actually, I'm not sure how to access this buffer. Maybe I should. It says index out of bounds. So it's there in the buffer. I'm not exactly sure how to access it right now.
It's all right.
All right.
Buffer is a pointer.
Yeah.
You don't have to dereference it. It's automatically done in Go.
But what do you mean? I'm sorry. Could someone help me with this?
Sorry?
I'm not sure what you mean. Could someone help me with this?
Okay, so whenever you have a pointer to some type, for example, if I have a type T, and if you have a some function over that type or some variable that is exported, you can directly access it. So you don't have to dereference it like in C. So in this case, and I believe.
Oh yeah, correct.
Yeah. So and in this case, I believe. So this is what I have read. that in case of unbuffered channels, there is no buffer, or although there obviously is some place where the value is,
Right.
I won't say stored, because value is not stored in case of unbuffered channel.
Actually, yeah, you are right. Okay.
Yeah.
Okay.
So
Yeah. Now it comes.
if you want,
The way.
yeah, if you want to tell, and yeah,
Sorry.
please continue.
Shall I? So the way
Yeah, sure.
it works in the unbuffered channel is that the receive queue and the send queue is what does the job. Like, so the send queue and receive queue, they directly are holding the value. So for example,
Yeah.
the send queue already has the value. So it has the information from where it's going to send the next value from. It's going to pick the next, so which goroutine has the value and where it's going to pick that value from. That information is available inside this headchan struct. So it does not actually use the buffer at all. That's why the queue count and data queue size will always be 0, just short circuits it. So it short circuits by just using the send queue. And when the next receive queue happens, instead of storing the new goroutine position inside the receive queue, it uses it directly copies this value from the send queues, so from the goroutines, from the sending goroutine's memory location into the reading goroutine's memory location. So that way you don't really need the buffer in a unbuffered channel.
Yeah. Great.
Right. Actually, this is all that I had. I think we have pretty much covered both unbuffered and buffered channels. References for this talk is Kavya Joshi's Gopher 2017 talk, Understanding Channels. Ankur Anand's Diving Deep into Golang Channels. I would recommend going through both. They are really excellent. They're excellently done material. Apart from this, I actually got started by looking at the Delve debugger, and then I had gone through the slides and everything. So my name is Gaurav. I'm a maker at Mithai Bhai, Silkmon, and Kodamana. I'm a volunteer and co-organizer at Chennai Gopher community. I'm an ex-consultant. I work with Circle Labs, Thoughtfuls, and Browser. I also help in running. I'm also a volunteer at the Go Study Group India, along with Dinesh, Praveen, and Wani, Mohammed Wani. He's also on the call. I think Dinesh also joined into the call. So that's pretty much it. This is where the code is for the talk, and these are my slides. Any other questions?
I guess no.
Okay.
There is a question in chat from Dinesh. It says, debugger that you used, can it be used from Vim?
Yes, you can set up Delve in Vim as well. Yeah, I mean, like, Delve is really awesome. I haven't, I've been playing around with it a lot, and yeah, I mean, yeah, it's been answered though. Any other questions? Any feedback on the presentations? Any comments on the presentations? Please go to the Go Study Group repository. The issues are where the talk proposals are proposed, so you can actually give feedback over there. And if you don't want to do it over call right now, so that's one thing. Yeah, that's pretty much it.